Well, hello, calculus students and seekers of truths. In this video, we will derive the quotient rule. So what we have here is a function q of x equals f of x over g of x. So it's a quotient. And what we want to do is find the derivative of q using some combination of f, g, f prime, and g prime. And normally what we would do is use the limit process. But I'm going to, and that's a perfectly good way to do it, but I'm going to show you in this video a slightly different way and what I call sneaking up on the answer, which is my way of saying we're not going to attack this problem directly. Rather, we're going to kind of dance around it a little bit. We're going to change the problem a little bit, and then suddenly the answer will appear. Okay, so this is a very helpful and useful approach. Now the first thing I'm going to do is actually I'm going to rewrite this as capital Q just because my Q's and my G's look really similar to each other, so that this won't be confusing to any of you. Okay? Alright, so we'll begin this way. Q of x is equal to f over g. And again, I'm not going to use the limit process. What I am going to do is I'm going to multiply both sides by g. Okay. And then what I'll do here is notice we have a product written here. So we're going to use the product rule. So we're going to take the derivative of both sides, right? So if these two expressions are equal, then their derivatives must also be equal. So the derivative of the function on the right side is just f prime. And on the left side, the derivative, remember we have to use the product rule, so it is the derivative of the first part, which is just q prime, times the second part, which is g, plus the derivative of the second part, which is just g prime, times q. Let me make myself a little bit more space here. Okay. So now we have a derivative taken, and notice here, this is what I mean by sneaking up on a problem. See here, we have q prime has now appeared in the problem. So rather than using the limit process to figure out the derivative of q, we rearrange the problem a little bit, and we use the product rule, and q prime has appeared in the problem. Okay? So now our goal here is just to solve for q prime. Alright, so to do that, let's go slow. Let's not rush things too much. So q prime times g is equal to f prime of x minus this part right here minus g prime times q of x. Okay. Now, remember that we want our answer in terms of f, g, f prime, g prime. So we don't want to leave this thing as q. So we can just change it back and maybe tweak and simplify the right side a little bit. So this is g prime. And this q of x here, well, what was it? Q of x was just f over g. And then I'm going to try to get everything to have the same common denominator. So this is a multiplication problem here. So we can actually put this entire expression over g. Okay, so let me just rearrange this a little bit, right? So this is really just g prime times f over g. Give myself a little bit more space here. And then I want to be able to combine this into the same fraction. So I'm going to multiply this f prime term here by g over g. So this is g of x over g of x. Okay, so multiplying by 1. All right, so now this big fraction here, we can combine all of that together. Okay, so let's see. I'm gonna, while I'm at it, just kind of rearrange things a tiny bit. This is on the right side, it's f prime g minus g prime f. So hopefully this looks a little familiar to you, right? That numerator, because it's nothing more than, it's like a slightly different version of the product rule. You have a minus sign here instead of a plus sign, all right? And it should look kind of like the product rule because we use the product rule to get to this point, okay? And then we're dividing this by g. Now on the left side, I have q prime times g. All right, so to finish this, get it down to its neat final form, we're going to get q prime by itself by dividing both sides by g of x, or in other words, multiplying by the reciprocal of g of x. So I'm just going to rewrite all of this. So we're dividing by g of x, but we already have a g of x down here, so this becomes g of x squared. Okay. So this is known as the quotient rule. This is also another rule that we use very often in calculus. And you know, these symbols here, f, the original expression is that f was the numerator and g was the denominator, so it looks this way. The way I always say it is, it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, so it follows this format. At some point, you're going to have to memorize this, but if you do a lot of practice, you kind of automatically memorize it anyways. So there you go. That is the derivation for the quotient rule. It's a rule that we use often, but most importantly, I want you to look at this in the sense of a different problem-solving method where we don't answer the question directly. We don't even use a limit process. We just make up our own problem when we kind of like sneak up on the answer. Thank you for watching and working hard. Ask for help if you need it, and have a wonderful day.